My name is Trinabh Suraj, and today we'll be talking about the operons, which is a form of gene regulation. Now, what is an operon? Well, an operon is a region of the bacterial DNA, which acts as a regulatory system for said bacterial DNA in plasmids. Here's an example of an operon. Its constituent parts are the promoter, which allows for the RNA polymerase to bind, the operator, which determines whether the gene is turned on or off, the gene itself, and this region known as the regulatory gene, which codes for the operator protein. As we see here, the operator protein acts like a light switch, binding to the operator, as we'll see in a minute. RNA polymerase transcribes DNA into RNA, and here we have either the repressor or inducer, also known as a co-repressor. This essentially binds to the operator, changing its shape and determining whether it'll be active or inactive. We'll first start off with the lac operon, which is an inducible operon, usually for metabolic processes. Here we have the lac operon. So this lac-I region codes for the operator protein, which is in its active form, meaning that when it goes and binds to the operator, it doesn't allow RNA polymerase to bind to the promoter, and therefore, or at least it doesn't allow RNA polymerase to continue transcription, and therefore the gene is not created, or at least mRNA for the gene is not created. However, if the bacteria is in a low glucose, high lactose environment, it creates an isomer of lactose known as allolactose, which binds to the operator protein, changes its shape into an inactive form, which then is unable to bind to the operator region, going out of system and allowing the RNA polymerase to bind to the promoter, beginning transcription and coding for the mRNA. Now we have the trip operon, which is a repressible operon, usually for catabolic processes. Here we have the trip operon gene. That TRIP-R region codes for the operator protein, which is in its inactive form, meaning that it cannot bind to the operator region, as we see here, leaves the system, which then allows RNA polymerase to bind to the promoter and transcribe the gene into mRNA. Now, what's interesting is that the TRIP-A region of the gene codes for an enzyme known as enzyme A, which turns one of the products of enzyme B into tryptophan, which acts as the repressor for this operon, meaning that when it binds to the operator protein, it changes its shape into an active form rather than inactive, and then that active form binds to the operator region, turning it off, meaning that there will be no transcription of the gene, which acts then as a cycle, because that means that there is no enzyme A being created, which means that the tryptophan will not be able to bind to the operator, which means that the operator will be at its inactive form, meaning that the gene will be turned on and the cycle continues. Now, I want to thank you guys for sticking around and watching this video. Like and subscribe.